Hey guys, welcome to FM343 of the Further Maths Fortify study guide. This question reads, Dylan is cleaning a couch. The couch has 3 seat cushions in the shape of rectangular prisms. All 3 cushions have the same height and depth, but different lengths as shown in the figures below. And then we're given some diagrams that look a little bit like this. The cushions have a height of 16 centimeters, so all the cushions have a height of 16 centimeters. The cushions have a depth of 51 centimeters. The volume of the largest cushion is 74,256 centimeters cubed. And then we're asked about part A. Before we go into part A, one thing I want to address is that a common mistake in this question is probably going to be thinking that this is to do with similar shapes. These 3 rectangular prisms are not similar. If they were similar, then this 1.3 times d as our width, well, we'd have a height that was also 1.3 times as long as that 16, and that depth of 51 centimeters would also be multiplied by 1.3. What you'll notice about these 2 cushions is that they've actually retained that 16 centimeters and 51 centimeters, so they're just 1.3 times as long, just a one-dimensional difference. In terms of the second and third dimensions, they're still retaining those. So this one is 1.3 times as long as this one, and this one is 1.2 times as long as this one. Cool. So jumping into A is asking us what is the value of D in centimeters? Round your answer to the nearest centimeter. Well, we know the volume of this cushion here because we've been told that the largest cushion has a volume of 74,256 centimeters cubed. So if we can use a volume formula, so our volume is going to be equal to length times width times height. We can insert the value of this cushion into the volume, so 74,256 centimeters cubed. The length, let's call that the 1.3 times d, so 1.3 d times width, let's call that the 16 centimeters, and height, the 51 centimeters. So we've got 74,256 is equal to 1.3 d times 16 times 51. This is where using the solve function of your calculator comes in very handy. So you're just going to solve for your unknown value d there, and using that you should get d is equal to 70 centimeters. Now when you're writing in your exams, it's not necessary to write solve. It is necessary, however, to show the equation that you're going to solve. So you would show this equation, and then you can just write d equals 70 centimeters after that, and that's a logical sort of progression there. Excellent. So part B then says, what is the total volume in cubic centimeters of all 3 cushions? Round your answer to the nearest cubic centimeter. So if we were to take the volume of the largest cushion and then add the volume of the middle-sized cushion or medium-sized cushion, and then add the volume of the smallest cushion, we would have our total. So we know that the volume of the largest cushion is 74,256 centimeters. We're going to add that to the volume of the middle cushion, so this cushion here, which is going to be, since we already know the volume of this largest cushion, the proportion that we're going to look at is 1.2 over 1.3. So we're taking 1.2 out of the total sort of 1.3 that we've got from the volume of this cushion, and finding sort of that proportion of the largest cushion, and that will give us the volume of our middle-sized cushion. We're going to do the same thing with the smallest cushion, except this time instead of putting 1.2 over 1.3, we're going to put 1 over 1.3, because there would be an invisible little 1 here in front of that first d. So we're now looking for 1 out of 1.3 of that same volume once again. Whacking that into a calculator, you should get an answer pops out at 199,920 centimeters cubed. And that would be your answer to part B. We're then given a little bit more information, which says Dylan realizes he is being silly and that the second largest cushion is from a different couch. In a futile attempt to make a beanbag, he tears the second largest cushion apart and tapes it back together in the shape of a sphere. C says, assuming the volume remains the same, what is the radius in centimeters of Dylan's makeshift beanbag? Round your answer to one decimal place. So what we've been told, so our focus is on this cushion now. What we've been told is that the volume of this cushion is going to be equal to the volume of our sphere, which the formula for the volume of a sphere is 4/3 times pi times r cubed. So we, of course, want this value here, this r. Now, if we were able to find the volume of a sphere, then we'd have an equation that we could solve for r. And in order to find the volume of the sphere, we simply need to find the volume of the cushion. So finding the volume of the cushion is actually going to be quite straightforward, because we used a formula to find the volume of this cushion before. We used 1.2 over 1.3 times 74,256. Plugging that into a calculator, you should get a volume of 68,544 centimeters cubed, which means you now also have a volume for your sphere. So we're going to make a little equation here. We're going to say that 68,544 centimeters cubed is going to be equal to 4/3 times pi times r cubed. And now we're going to once again use solve. We're going to solve for r, and we should get, when we've rounded to one decimal place, r is equal to 25.4 centimeters. If you guys have any questions about these questions, please leave them in the comments below. Otherwise, I'll see you in the next video.